Welcome to Mimi's Math channel. Today I'm going to discuss using Desmos for real-world rational function applications. So for example 1, Jaden can clean a large tank at an aquarium in about 6 hours. When Jaden and KJ work together, they can clean the tank in about 3.5 hours. About how long would it take KJ to clean the tank if she works by herself? So the first thing you want to do is set up proportions and set them equal to what they can do together in this case. And it would look like this. So for the first proportion, this is referring to Jaden. So she can do one job in 6 hours. We don't know how many hours it would take KJ to do her job, but we know together it will take 3.5 hours for both of them to do the job. So now I can just go ahead and find my least common denominator. And what I would suggest that you do is just take both those numbers and multiply them. And so 6 times 3.5 is going to be 21. But then I also have an x in the denominator. So I have to take into account all three of the denominators in order to find my least common denominator. So then what I want to do is take each fraction and multiply it by what's on the outside, which is 21x. Well, really, it's 21 divided by 6 in this first fraction. So that's going to just end up being 6 times 3.5. And once I multiply that information out, I'm going to get 3.5x. So again, what I'm saying is I'm going to have 1 over 6, and I'm going to multiply that times 21x. Well, if I really divide that, that's going to leave me with 3.5x. So that's where that's coming from. And I'm going to do that for each fraction. So for the next fraction, I already have an x. So once I multiply that times 21x, the x's go away, and I'm just left with 21. And then for the next one, I'm going to have the 3.5 that I'm going to really divide by 21. Because I'm multiplying it by 21x. And once I divide that, that's going to leave me with 6x. And now I just use my algebra skills and I combine my like terms. So that's going to look like this. And my final answer is going to be x is equal to 8.4 hours. Now let's verify that using Desmos. If we go to Desmos, and I've already typed it in, it looks like this. Well, if I click on this, I can't really tell what the answer should be. So what I would suggest that you do is this portion that's after the equal sign, we normally set up our equations as y equals. So equal means that they're balanced on both sides. So either one of these could be y. So this could be y equals over here, and this also could be y equals. So let's just take this portion. So I'm going to put y, and then I pasted that information back in. Now, it tells me that y should equal 0.2857. So I'm going to look over here where the graphs actually meet, because the red one represents the left-hand side of my equation, and then the green one represents the right-hand side. Where they're intersecting, that's my answer, my x value. So where y is 2.286, which is this rounded, then this is my correct answer, 8.4, which we already said once we work it out manually. So now we want to go to the next one. And this one says a jet travels 3,950 miles from Chicago, Illinois to London, England, and 3,950 miles on the return trip. The total flying time is 16.5 hours. The return trip takes longer due to winds that generally blow from west to east. If the jet's average speed with no wind is 485 miles per hour, what is the average speed of the wind during the round trip flight? Once we find our answer, we're asked to round it to the nearest mile per hour. So I would suggest that you set up a chart where you have your distance at the top and one of your column headings, your average speed, which is the miles per hour, and then the time, which is represented in hours. So we're told the distance going to and from is 3,950. So that's where this first column comes from. And then here we're told the average speed is 485 miles per hour, but going to, there was no wind. And then coming from, there was wind. So that's why we have one that's a plus and one that's a minus our variable x. And now we want to actually set them. We're setting up rational functions. So we're going to take the distance and then we're going to divide it by the speed, the average speed here. And we're going to do that for both. And this is what it will look like if you manually set this up. So I'm going to do the same thing, and I'm going to find the least common denominator. And I see that I have in one denominator 485 plus x. In the other denominator, I have 485 minus x. And then 16.5, the denominator is 1. We don't really have to take that into consideration as far as putting it on the outside, but we do have to know that this is actually a fraction. What I would do, and I'm just going to go ahead and multiply this out. So 485 times 485 is 235,225. Because there's a plus and a minus x, the middle is going to zero out. So I'm just going to multiply them. Negative x times positive x is negative x squared. Okay, so now I'm going to do what I did a few minutes ago. The first fraction's denominator is 485 plus x. So I don't have to consider that on the outside here. I can just multiply. I can cross those out. So once I cross those out, I'm left with this 485 minus x, which has to multiply times the numerator that's currently there. So now I'm going to go to the next fraction. I'm going to add this answer, and I'm going to take what's already there, get rid of that, and what's left over, I have to multiply those two things together. All right, so now after the equal sign, I have 16.5, but I don't have anything in the denominator other than 1. So I'm going to have to multiply all of this times the 16.5. That's why I went ahead and multiplied it out, because I knew that was coming. And this is what my answer would look like. Now I'm going to combine like terms, but what I'm going to do after I combine like terms is I'm going to move this x squared portion to the left and then move my constants over to the right. So manually, this is what it would look like. And let's go over to Desmos, clear this out, and type in the original function. So I've typed in the rational function, and I know based off of my manual answer that it should be around 55 for x. So I'm going to go over on my x-axis over this way. And again, I see that it's near 55, but it's not exactly there. So I can do what I did a few minutes ago, and I can take the equal portion and set it equal to y. And so now what I want to do is look at the two different graphs where they actually intersect. And I see if I actually click on it, this does tell me that 54.89, that's rounded to 55, because we were asked in the problem to round to the nearest mile per hour. And 16.5 is what the y was supposed to equal. So that's how we know we got it right. And this is the correct answer, rounded. And I just wanted to also just make note of, sometimes they will ask you for a time, and sometimes they'll ask for a rate. So if you understand that the formula for distance is equal to rate times time, then you can just manipulate this formula. In order to find time, you would have to divide both sides by the rate. So that's why we have distance divided by rate. And in order to find the rate, we want to isolate r by itself and move time over. So it will be distance divided by time. And that concludes the video. Thumbs up, subscribe, and have an awesome day.
Subscribe.